Welcome back, folks. We're going to look at another superposition problem. This is going to be the first time we have a dependent supply in the problem. You're going to run into this if you have to analyze a circuit with a transistor. You might model it with a dependent supply. And if you have multiple frequencies in that circuit, you may want to do superposition on that problem. So here's a toy problem. It's simple enough that we can apply what we know now and use it as a stepping stone to some of that more complex analysis. Okay, so here, how many supplies do we have? We have 3, right? 1, 2, 3. So the question is, how many subproblems do we break this into? And the answer is, go back and look at the steps that I put up there for superposition. You count the independent supplies. So really what I'm looking for here is how many independent supplies do I have in the problem? And the answer to that is 2. This one's dependent. These 2 are independent. Okay, so only 2 subproblems for this one. If you're following along in the notes, I flipped that polarity around. I don't know, I wanted it positive on the top, just for fun. So there is a difference between this and what I have published in my unedited, off-the-cuff notes that I base all of these lectures off of. Okay. Believe it or not, there's still, as much as I've written on that stuff, a lot of knowledge is up here. So subproblem number 1, I've got to pick one of these independent supplies. I'm going to pick the current supply, and I'm going to replace all of the other independent supplies. Now, what happens to the dependent supply? It stays right where it is. Okay? So I replaced a voltage supply with its ideal resistance, and I'm looking for the first part of I out. And now this is dependent, but it's dependent on the first part of I out. Okay, so if I'm being careful, I'm going to get that subscript in both places. Now we go do the analysis the way that we always have. So I'm going to do mesh, because that's my preference. You can do whatever you want, but you should end up at the same place when all is said and done. So it looks like what we've got a super node. I got nodal on that brain. You do too, probably. We've got a super mesh around there. So I'm going to write 1 KCL and 1 KVL. Now, the KCL is going to be nice and easy because it doesn't involve that dependent supply. But the KVL, I'm going to stop. I'm going to go slowly, and we're going to make sure we get it right the first time. Okay, so it's going to be a 2 by 2. Does I1 touch the current supply? Yes, and it goes in the opposite direction. Does I2 touch the current supply? Yes, and it goes in the same direction. Look at that. That one was easy, and that's all equal to 2. Okay. Right behind my head. Man, I wish I could write things in my brain. I think I've been in this basement too long. Okay, KVL for the super loop or super mesh, whichever one you want to call it. We're going to go up across VS, and that is 2I out. So it's 2I out. And it's the first part of I out. We're going to drop across the 12 ohm, and that only has I1 flowing through it. We're going to drop across the 6 ohm, and that only has I2 flowing through it. And then we're back to where we started. So that's equal to 0. So not quite in the form that I want, because I still have this here. Okay, and that is not a constant, and that is not a mesh current. So I've got to figure out how to express that. So we're going to replace that with the expression for I out, which is, well, let's start it like that. Does I1 touch that I out? Nope. Does I2? Yep. Does it flow in the same or the opposite direction? It flows in the opposite direction, so it's going to be negative. So now we plug in this anywhere we see the first part of I out. So we have negative 2 I2 minus 12 I2 minus 6, minus 12 I1, almost did it, minus 6 I2, and that's equal to 0. So group your like terms. I1's all by itself, but you've got 2 that have coefficients in front of I2, so we're going to get negative 8 I2, and that's equal to 0. All right, you can come up here, plug that in. 0 on the right-hand side. Solve it any way you want. Okay, so -1, 1, 2, -12, -8, and 0. -800 milliamps and positive 1.2 amps. Those are the mesh currents. Hey, we've already got an expression right here. We already wrote it. So let's go ahead and steal it. Right. So it's going to be -I2 is -1.2 amps. And that is our solution for the first subproblem. Okay. Break up these subproblems, right? Subproblem number 2, and there's only 2 in this problem. I need to go copy it again because I got rid of it off my clipboard. There we go. Okay, stick it in there. We did the current supply before. Now we're going to say, what does the voltage supply do? So we remove the other independent supplies. We leave the dependent supplies. And we replace the independent supplies with their ideal resistances for the current supply. That was a current supply. It's going to be an open. Okay, so that's just going to lay open. We've only got one mesh. It's kind of nice. Only one equation. And no current supply, so it's going to be a KVL. And it does involve a dependent supply, so I am going to go a little slower on this one and make sure I get it right. So let me just do this over here. We're going to go up to I out, and this is the second part of I out, right? It's a distinct value from the total I out. Okay, we're going to drop across the 12. We're going to name this some, let's just call it I, right? And we're going to drop across the 12. We're going to drop across the 6. We're going to, oh, we got a constant here. We're going to drop across a constant 12 volts. And we're back to where we started, so that's equal to 0. We got to do the same thing where we write an expression for I out. Look, it's going to be different because I only have one current now. So that's why I say draw that, draw that firewall. Don't reuse any of the analysis. You're going to get yourself into trouble if you do that. Okay, so let's see. Does I touch the second part of I out? It does, and it flows in the opposite direction. So we plug that in. So we get -2I, -12I, -6I, and I'll bring that 12 over to the other side. And all together, let's see, we got 14, we get -20I equals 12. So I don't even need a calculator for that. I can just go 12 over -20. What's that going to be? That's not going to be oh, it turns out I need a calculator. I don't trust my brain. I know it's simple. If I was on a desert island and I didn't have a calculator, yeah, I would have gotten it right. 600 milliamps. I just don't trust myself. Should I? 600 milliamps. Should I trust the calculator more? I don't know. All right, getting the expression for the second part of I out. Well, we already did that, right? So same game here. I'm going to bring that down here, and it is just equal to -600 milliamps. Okay. Behind my head again. There we go. -600 milliamps. All we got to do is sum it up. Bring it up here. Do I have room up here? You think I got room? Ooh, it's going to get cozy. Squeeze it in there. And you know what? What a horrible decision. Let's just do this. Okay, sum it up. There's no reason to fight. We got more paper down here. I out equals the first part of I out plus the second part of I out. All right, so this is negative 1.2 amps plus negative 600 milliamps. So make sure that you're algebraically summing it. Get those signs down in there as well. Okay, and we're going to have negative 1.8 amps. There's your solution, okay? And that's the final answer we were looking for. Not too different from what we did in the previous 3 videos. It's still superposition. We're still breaking it up based on the number of independent supplies. The dependent supply stays right where it is. The control variable stays right where it is. Okay, in all of the subproblems. If you break this into 3 subproblems, you're going to have a world of hurt. You only need to do 2. You're going to do more work, and you're going to, you're going to get the wrong answer. Nobody wants that. Okay, I think I have one more of these just to give you a little bit of repetition on the same concept, and you'll be doing well with superposition. Then we got a short homework assignment for this one. I know you're excited about that. Stay tuned and good luck.